Today we are going to do first translation theorem. Before we start first translation theorem, let's look at some background. Here is what we have done before. We have done Laplace transform of three kinds of functions. We have done Laplace transform of t power something, let's say t power square, so that is 2 factorial over s power 2 plus 1. We have done Laplace transform of e power something, let's say e power 3t, so that is 1 over s minus 3. We have also done Laplace transform of trigonometric functions, but only sine and cos, hyperbolic. So let's say if we have cos of 4t, so that gives us s over s square plus 6. So we have done three kinds of functions. Well, we also did hyperbolic, but I'll consider them in the same time. Now, we know how to find Laplace of t square, any power of t, any power of e power with a constant here, not t square here, and then cosine, sine, cosine, or hyperbolic sine and cosine. So we can see them here. What if the situation is changed and we are given a multiple of two functions? For example, t e power 3t. Now, t is multiplied with e power 3t. Does any formula help us in this situation? So t, we know how to find Laplace of t power 1, e power 3t, but not multiplied, separate. Okay? How do we do this one now? How do we do this one? Well, the very first thing that comes to our mind, or might come to our mind, that we can try to do this thing. We can try to Laplace of t e power 3t, and we would write to, I'll write some names so that it's recorded. Not equal to Laplace of t multiplied with Laplace of e power 3. That is a very important result too. Very important. We cannot split Laplace over multiplication. We cannot. This will be wrong. This is not equal. We cannot write Laplace of t separate and e power 3t separate and then use the formula t here and e raised power 3t. That is not possible. Okay? I have mentioned this situation in our formula sheet as well. If you look at L21, Laplace of f of t multiply g of t is not equal to Laplace of f of t Laplace of t. Not. So this is not possible. What else can we do in this situation? If this is not possible, so what should we do? There is a special formula for this situation. There are other multiples possible. For example, the other multiples possible is Laplace of t cube with sine of 4t. Maybe we will talk about this later, but not right now. Right now, we are only considering if e power something is multiplied with the function. E is multiplied with this, with t power or with sine of. So formula is Laplace of e power at, so e power some constant into t, f of t, where f of t is either t power or sine cosine, is goes to, what we do is we only take Laplace of f of t. So when we get a situation like this, we only take Laplace of f of t. Where did e power at go? Important question is, where did e power at go? Because we cannot ignore it. It's there. So we must do something to compensate for e power at. So what we do is, after taking Laplace of f of t, which will be a function of s, after when we have taken Laplace of f of t, it will be a function of s. We will shift s to s minus a, this a here. We will shift s to s minus a. In other words, we will write f of s minus. I'll explain it with an easy example. So let's say if we have Laplace of t, fashion, e is power 3t and a t. Okay? So our f of t is t only, and a is, and from here we see that a is 3. Right. So now formula says that take Laplace of f of t, which is t only, and then shift the answer by a. A is 3 in our case. Let's say, what is Laplace of t? Let's go back to our formula. I'll write it down here. Laplace of t power n is n factorial over Sn plus 1. Okay. That tells me that the Laplace of t is 1 over s square. And we have to make the shift. Why do we have to make the shift? Because we took Laplace of t only, and we were supposed to take Laplace of the multiple. So to compensate, where did e power 3t go? It is here. E power 3t is contributing here. So that becomes 1 over s minus 3 whole square. This shift is very important to understand, because this will we will use this shift in next 2 or 3 topics. So it's very important. How does this shift work? Let's see. So once again, the question is find Laplace of. The question says find Laplace of t e raised power 3t. What we do is we ignore e power 3t and just take Laplace of t. But actually we don't ignore. We put e power 3t here. This 3 is coming from this 3. E power 3t is appearing over here. And once we take Laplace of t, we shift. Okay? Substitute, you can say, but we use the word shift. Yeah. Shift. Okay. Just the title says. First translation theorem. Translate. Shift. Okay. Our first shift theorem. Also called shift theorem. So we shift s by s minus 3. Notable point. 1 over s square. That's our function. What if I want to put s equals 4? What will happen? 1 over 4 square. Okay. If I want to put, let's say, 1 over s square, and I want to put s equals 7, what will be the answer? 1 over 7 square. What if I want to put s equals, let's say, b? What will be the answer? 1 over b square. You are right. Okay, let's try one more. 1 over s square, 1 over, and we want to put s equals b plus 3. Can I write s square plus 3? Am I right? Think about it. If I put s equals b plus 3, is that correct answer? Think about it. Pause the video. Think about it. Right. No, this is not the right answer. This is not the right answer. What is the right answer then? What is the correct answer here? The correct answer is 1 over b plus 3 whole square. That's the correct answer. Okay. Now let's keep it back. Right. That's square remains outside and b plus 3 goes inside the square, replaces x. Okay, replaces x. All right. How about 1 over s square and s goes to s minus 3. So what do? We do is 1 over, we treat this function as like this. Okay? S square is something square, and that something is replaced with s minus 3. So it becomes 1 over s minus 3 square. Okay? Square is still outside. Okay? That should be remembered, that square is still outside. And this would be wrong. 1 over s square minus 3, that is wrong. Okay? That should be remembered. We must understand the shift operation for next 2 or 3 topics. Please pause the video, have a look at it again, and we will do one more question and give it a try. The Laplace of, it is exercise 4.3. Question number 1. Find Laplace of t e raised power 10. Okay. Now our function, this is our function f of t, and from here we see that a equals 10. Our formula says take Laplace of the function. Take Laplace of the function and then shift by s minus a, where a is 10. Okay, so that goes to Laplace of t is again 1 over s square and s goes to s minus 10. Alright, pause the video and try to do this last step. Just one last step. Look at the explanation I've given in the previous question and try to do this last step. I'm going to write 2 answers. Choose one. Okay. Which one is correct? Number 1, 1 over s square minus 10. Number 2, 1 over s minus 10 whole square. Choose. Which one do you choose? Okay, here's the answer. This one is wrong. This one is right. 1 over s square, when we replace s. Okay? Not just do minus 10 from the function. No, we are not doing minus 10 from the function. We are replacing s. We are treating this as 1 over this square. And this thing is replaced with here. So s is gone and s minus 10 has come in place. Okay? Like this. Okay? Alright, let's try one more. Let's try an easy one. Question number 4 from the exercise. Laplace of t power 10 e raised power minus 7. Okay, pause the video. Give it a try. Now your turn. Okay, so let's see what do we get. Again, what is the function? What is the function? Function is over here. That's the function, f of t. And a is minus 7. Note that a is minus 7, not plus 7, minus 7. Alright, Laplace of f of t, which is t power 10, and s goes to s plus 7. Why plus 7? Here, s goes to s minus a. This minus in the formula. So, s minus 7, that will give s plus 7. Alright, what is the Laplace of t power 10? It is 10 factorial over s power 11. And then s goes to s plus 7. and this means 10 factorial over s plus 7 whole power 11. Again, note that we are treating it as 10 factorial over something power 11. Here is where we do the replacement. S plus 7 goes inside the power and becomes s plus 7 whole power 11. Power remains outside. Okay. Let's try one with sine or cos. It is question number 7. It is Laplace of e power t sine of t. What is the function here? What is f of t? This is f of t. How do I know that this is f of t? Why e power t is not f of t? Can you tell me why e power t is not f of t? Why sine 3t is f of t? We have to go back to our formula to have a look at this. Look at the formula. E power at f of t. So always we are given some e power and some function. So e power is only telling us about a. This is telling only about a, and the other function with it is f of t. Okay, that's where we take the Laplace. What do we have here? E power t. So a is 1. This is telling me what is a. This is my f of t. So how does the formula work out in this one? Can you give it a try? Give it a try. Just write the first step. Just one step. Write one step. Pause the video and try to write the first step. Just this next step. Very good. Alright, let's see. Laplace of the function, which is sine of 3t, and shift s goes to s minus a. What is a? A is 1 in this case. Okay. What is Laplace of sine 3t? Anybody remembers? Sine 3t. Here it is. Sine kt. So 3 over s square plus 9. So that is k over s square plus 9, and s should be shifted by s minus 1. Do we have any s here? No. So 3 remains. No change. S square becomes s minus 1 square plus 9. No change in 9 or 3. Only s is replaced by s square minus 1. S minus 1. First of all. So we look at the formula. We look at the function like this. 1 over s square plus 3 over s square plus 9. We look at this 3 over something square plus 9, and here is where we make the change. Here we replace s by s minus 1. S is gone, s minus 1 has come in place. So it becomes 3 over s minus 1 square plus 9. That's a very careful step. All the s in the formula should replace. I'll give you couple more examples how the shift works, because after this you are going to see a quiz. Let's say if we have for instance, although e doesn't come in Laplace, not in this topic, it will come later, but let's say if we have s cube minus 1 over s into s plus 1, and we have to shift s by s plus 4. Try to write the answer, please. Pause the video, try to write the answer. How would you shift this thing? Right. So this becomes s plus 4 cube minus 1 over s plus 4 into s plus 4 plus 1. Look at the change. Look at the change. I'll write this. I'll write this red. So here there was an s and replaced by s plus 4. Here there is an s and replaced by s plus 4. So this s is gone. This s is gone and replaced with that. We need bracket because there is only one s, and here we have s plus 4, so we need a bracket. S replaced with s plus 4. We need a bracket because now the term has two terms in it. Here s, this s, and this s replaced with s plus 1, no change. Okay? So do you get the idea? Let's try one more. Let's try. I'm going to include e power as well this time. E power 3s plus 7. I'm just trying to make it more complicated so that you can understand the story. We won't see this kind of functions in our Laplace, but I just want you to understand the shift. Okay? Over s square plus s, and we are shifting it by s minus 1. Alright, pause the video, give it a try. So this becomes e power 3s minus 1 plus 7. Note the beauty here. This s is multiplied with 3 and plus 7. We treat it as e power 3 multiply something plus 7. Here is where s minus 1 comes. 3 multiply s plus 7. 3 multiply something, the function, the s, and plus 7. So s minus 1 will replace s over here. Over, where is s? S square. So s minus 1 square plus s minus. I hope you got the idea. Now we will go to a quiz. Please do the quiz. It will help you understand how shift works. Right. Let's do a couple more examples. Question number 8 here. Laplace of e raised to power minus 2t cos of 4t. Okay. Alright, pause the video, give it a try. Now, this is your f of t, and this tells you that a equals minus 2. Alright, give it a try. Let's see. Laplace of the function, which is cos 4t, and shift by a, which is minus 2. So this becomes plus 2. Remember, please remember, this one is very important. S goes to s minus a. S minus minus 2. So that's why we must remember that this is a plus 2. Okay. Alright. And now we get that is equal to, what is cos of 4t Laplace? It is s over s square plus k square, which is s over s square plus 16. And s goes to s plus 2. And that is s over s plus 2 square plus 16. Did I do it right? Have a look at the answer. Did I do it right? Did I make a mistake? Do you see a mistake somewhere? Pause the video, look at the mistake, find the mistake. How about here? Why I did not shift this s? Yes, that's wrong. This is wrong. This is wrong because I did not shift both s. Must shift both s. What is the correct answer? Correct answer is s plus 2 over s plus 2 square plus 16. Must shift both the s. Okay? Must shift this s plus 2, okay? And this s replaced with s plus 2. Okay? Not only this one. So this is wrong. This is wrong. This one is correct. Please remember the difference. Okay, question number 10. Laplace of e is equal to 3t into 9 minus 4t plus 10 sine t by 2. First of all, we have to multiply e power 3t inside and make separate functions so that we can split Laplace over addition. We can split Laplace over addition. We cannot split Laplace over multiplication or division. Okay, remember that. Where does it say in the formula sheet? Where does it say in the formula sheet? Let's look at the formula sheet. So here's our formula sheet. Here it is. It says if f of t plus or minus g of t, we can write f of t plus minus Laplace g of t. We can split the Laplace over addition or subtraction. That's okay. But we cannot do this for multiplication or division. Okay? So our first step is okay. We have three functions. There's this function, then a minus, then another function plus. So we can treat them as, so this one, and this one. And we write equals Laplace of 9e power 3t minus Laplace of, well, I'll take the constant out. It is obvious that constant will go out. 4 times t e power 3t plus 10 times Laplace of e power 3t sine t by 2. Now we have this first. Does this involve shift theorem? Laplace of e power 3t? What do you think? It does not. It's simple. One function, no other function multiplied. So it's simply Laplace of e power at minus 4 times. This involves shift theorem because there are two functions multiplied, t and e power 3t. So we do Laplace of t and then shift by s minus a. Well, a is 3 in this case, so we must write 3. 10 times. This also involves shift because two functions multiplied, e power 3t sine 2 t by 2. So we do sine t by 2 and then shift by s minus 3. Okay, because 3 is again our a. So 9 over s minus 3 minus 4 over s square. S goes to s minus 3 plus, there was one minus, yes, that's right, 10 t by 2. So that is 1 by 2 is our k. Okay? K over s square plus k square, and s goes to s minus 3. I'll keep these two steps in picture. 9 over s minus 3 minus 4 over s minus 3 square. Remember that s minus 3 goes inside the square. 1 by 2 comes down and makes this 5. So we'll write 5 over s square plus 1 by 4. Well, we will do the shift in the same step. There's no harm doing it. So s minus 3 square plus 1 by 4. Again, remember s minus 3 goes inside the square here. And that completes our this part. Now you'll do another quiz just to do things